Hi, everybody. So today we want to talk about the intersection of geographic data, augmented reality, AI, and maps. And as we've seen already, machine learning has some real utility in geographic analysis and communication. Moreover, other companies such as Esri and Google offer AI-enriched analytical tools at traditional GIS scales. Nevertheless, today we're focusing on another company, Niantic, because it claims to be doing some novel things utilizing augmented reality for extremely high, e.g. centimeter scale resolution data, and synthesizing geographic data where it is missing or insufficient. That said, if you know of any firms working along similar lines, we'd love to hear about it. That said, we are in no way affiliated with Niantic. Rather, what we are doing, or what we're asking, is what would this kind of service mean if it works? And that's very much an open question. But if it works, what would it mean for geographic data, cartography, and ways of knowing the world? We're very much mid-process here, so today we're sharing our progress on this thus far and untangling some of these developments and their social implications. So, Niantic is best known for Pokemon Go, which went viral 9 years ago. And it ported licensed Pokemon intellectual property into a geolocated augmented reality mobile game, breaking such smartphone games into a popular imagination. Niantic was a spin-off of Google's Geo division, headed by John Hanke, Google Geo's former VP, and before that, the CEO of Keyhole Inc. If you've never played Pokemon Go, the game mechanics are a combination of GPS scavenger hunt and cockfighting. It's just with Pokemon branding. And what makes this and other Niantic games different is that they are real world and location based. So walking around your neighborhood will make your avatar walk around a reskinned map in the game of your neighborhood. So in-game features like supplies, Pokestops, and fighting at gyms are tied to specific locations on Earth selected from Niantic's point of interest database. Moreover, the process of catching Pokemon reinforces the visual connection between the game and the street using augmented reality. So by default, it's the second image from the left over there. So by default, the game places Pokemon characters on top of a view of the player's surroundings provided by usually the phone's camera. After Pokemon Go's success, Niantic has launched several other similar games, though none have had similar success to Pokemon Go. Now, Pokemon Go, for all of its cute licensed Pokemon, was only possible with an unusually rich combination of geographic data, and that is no small challenge. These games required a worldwide base map, which since 2017 has been OpenStreetMap, and Niantic's own proprietary world-scale point-of-interest database with sufficient density for pedestrian use. That POI database is valuable, and it serves as the basis for in-game Pokestops, gyms, and all that other fun stuff. Now, some of these POIs are derived from OpenStreetMap, but others are directly crowdsourced from other Niantic apps and players in the game, including a crowdsourced tour guide app and player-generated sites in Ingress, which is the precursor to Pokemon Go. At the same time, Niantic collects not just POIs, but also geolocated photographic data, initially from crowdsourced images around POIs, but with Pokemon Go, you can get all of that photographic data from the augmented reality component through the passive collection of data as people play it. So, over the years, Pokemon Go's buzz has faded, though the game retains a reasonable playership given its age. Moreover, the company's more recent games have not been hits. So in this context of a growth-obsessed technology sector, what are they to do? In recent months, Niantic announced two major changes. First, they're selling their games division, including Pokemon Go. That will no longer be a Niantic property for $3.5 billion to Scopely Inc., a major games company backed by Saudi capital. Second, they're launching a new spin-off, and that's what we're driving at here, named Niantic Spatial, with $200 million from that transaction, an additional $50 million from Scopely, and more investors like Snap. In this spin-off, Niantic Spatial has announced multiple partnerships with game studios and data intelligence firms, and this expansion from geospatial games to data intelligence using geographic data collected from the game is very similar to what Foursquare did a couple of years ago. Now, Niantic Spatial's plan is to build a new kind of large model artificial intelligence, what they're calling a large spatial model, excuse me. So, ChatGPT and other famous AI systems are large language models trained on deep learning methods using massive amounts of data, usually scraped from the web. Niantic's building what they called a large geospatial model. But here the training data seems to be primarily images and points of interest, focusing on text, and the output is in latitudinal and longitudinal space. So before we be clear, I want to be very clear about this. This is all pretty new, and it's coming from a technology company that hasn't had a major hit in almost 10 years. This absolutely could be vaporware. An attempt to attract new capital and growth with the new shiny fetish of the moment, AI. However, in the deal with Scopely, Niantic is keeping all of that data that they've collected for more than the last 10 years. And that value should not be underestimated. Those are likely one of the largest geographic imagery and POI databases in existence, comparable to Google Geo. And unlike ChatGPT or Anthropic's web scraping of data, Niantic owns that data. It's their property, harvested from crowdsourcing, including AR imagery, as we mentioned earlier. And with that, I'm handing it over to Jim.
Hey. Good morning. So this new spin-off and bifurcation of Niantic is all quite new, right? We're writing about this now. But the more we looked into it, the more we see in it layers, like an onion, of how AI, spatial data, and capitalism come together in both ways that follow old pathways and demarcate new ones. In the remaining few moments, let me sketch out a few more layers of that onion. One way to see what they've been up to is to just take a gander at their GitHub repos. It's a good place to go. With a full caveat towards the limitations of open source and its relations to venture and private capital, this still gives us an outside look into what and where they are contributing code, where they themselves are working, and as part and parcel of how for-profit industries make use of open source, where they are encouraging others to. What we can see is a focus on extracting 3D information from 2D images, and that just fascinates me. This is, from a pure math and computation perspective, incredibly interesting. Not to digress terribly far, but it's an attempt to reverse the loss of information intrinsic in dimension reduction. Usually when you reduce the dimensionality of your data, information is lost. We understand this because we know how map projections work, right? You go from a 3D globe to a 2D map, use a projection that necessarily distorts and represents in some ways, making Greenland as big as Africa and the classic Mercator, for example. Well, these repositories are about being able to infer the missing information and reconstruct the higher dimensional space from the lower dimensional representation, and to be able to do it really, really fast, which is just cool. The image here is taken from one of those repositories on the last slide, the Mickey one. I really love their use of silly acronyms. But in it, you can see what Mickey tries to do and does allegedly much faster and better than competitor libraries. It infers spatial relations between images. In this case, it can see that the two images are of the same object taken from different sides. I've paired it from a quote taken from Niantic's blog when they announced their AI, which, it should be noticed, caused a flurry of media coverage about how they had secretly been using players to train the AI, a typical cycle of what Craig and I have called the who could have known style of disaster tech capitalism news coverage. And we can see here the basis for their supposed LGM. They have asked players to scan scenes, to take images of places while playing Pokemon Go. It's an optional activity, but it's an incentivized one, and it results in upwards of 1 million scenes scanned a day. These are then fed into their neural network and to the tune of trillions of parameters, and out spits an LGM, something that has the explicit goal of being global and totalizing. But it raises some kind of age-old questions. First, of course, is the age-old issue of whose spatial data. This map is of where scene uploads, the backbone on which their AI works, occur. While the relevant XKCD is always welcome here, there's a deeper issue at work. This is specifically urban, specifically global north, map of the world for the most part. All of those churches the LGM will see and be able to infer the other side of won't be churches in sub-Saharan Africa. And this, of course, ties in directly to the world that AI can see. This LGM is the first of its kind, and it can see and thus imagine a specific kind of world, one limited by the data available to it, and that data in turn follows historic patterns of exploitation in global north, white, patriarchal-centered gazes. This layer is both old and new. Old in the sense that we know that networks built on networks, infrastructure begets infrastructure. We know that Silicon Valley exceptionalism's gaze is always a narrow, limited one, rooted in exploitation, rooted in structural racism. It's also old in the sense of how it treats privacy. You can upload as many scenes as you'd like and have them pinned publicly in Niantic's database, used for further training their AI, and also queryable by anyone using their API. Similarly to other trends, if you want your spatial information to be kept privately, well, that costs a lot, actually. It's like a couple $100 per 10 points. Time's up? Oh, God. But it's new in the sense of what it's trying to do and how. It leaves us the question of what churches, what villages will this AI not be able to imagine? What hallucinations may occur when confronted with a cultural object outside of what's encountered previously? A remote, natural area. I don't know. There's the XKCD. I'll end here, sorry. Here's how much it costs. It's really expensive. A second layer to the onion underscores the purpose of this model. Over and over again, in quote after quote, we find two key themes. The first is that this is a map for machines. Second is the reduction of the experience of the spatial world to one of inches and centimeters, to absolute Newtonian units of measurement. Elided from the LGM is any consideration of concepts in geography that range from composites of place to other affective and experiential measurements of the world. This is Barth's one-for-one map of the world. It is a Cartesian grid placed in their ideal upon all things in real time. But rather than ending up useless and discarded in the desert, this one is aimed at allowing for machines to function in both economic and, one very quickly realizes, military purposes. So that's another layer of the onion. And I've run out of time because I've meandered too much, but I will leave you with this. It raises the question of if this is simply creating a spectacle for machines rather than just a map, an endless series of images training an endless series of neural networks to be able to see and place within absolute Newtonian space again, more and more with less and less meaning behind it. And undergirding all of this, potentially, a space of glitches and inferences gone awry. From limited training data, a world imagined as a complete Cartesian grid, but in reality one filled with hallucinations built from images scanned millions of times. And this, then, we hope, leaves open a moment for politics.
Say we have time for one question.